Okay, thank you very much for the opportunity and being able to get in front of everybody to present the service that Colt provides. Transform oil, SF6 gas, and nitrogen leak repairs. And it's all of it's really done with no draining or depressurizing the system. Some of the stuff's done energized depending on where it's located on the transformer naturally, but I'm the division manager. Just a quick little information on me. I started back in 1980 in the field as a technician, worked 11 years fixing steam and chemical leaks, held various positions since that time: supervisor, sales, branch manager, field supervisor. And then in 2002, I started technical sales with Colt Power Services Division that does nothing but oil, SF6 gas, and nitrogen. And then in January of 2019, I became the division manager. This is a leak I was dressed up for, the last steam leak I fixed back in 1994 inside a containment at Diablo Canyon. We went in after a leak that our competitor had a injection valve on a steam generator root valve blow off, and myself and another technician had to go in there and stab another valve on there and pump it up and seal it off. That's what we did there. Now moving ahead about 8 years here, big thing with transformers, you don't want to get air and moisture in them. And because of Venturi effect, if you have anything leaking out of the transformer, oil or even nitrogen or whatever, you can get moisture and air coming in from the Venturi effect. So that's one of the reasons for our repair techniques. Some of the reasons that leaks occurs: transportation, temperature changes, vibration from normal operations, a sudden removal from service, the weather environment, incidents, and then human factors. A lot of times we'll find people replace gaskets that are the wrong gasket, or somebody's backed into a radiator and put a hole in it. And if you fill it, it will leak. Options of dealing with leaks: you can let it leak, you can regasket, or you can do in-house repairs, or you can use repair specialists like Colt to come in and make the repairs. And this is just a leak here. We have this on one of our flyers for this event too, but this particular one, we could have fixed it, but by the time we was going to get out there, which would have been a 4-hour drive, that it would have been drained low enough anyway where they would have had to bring the transformer out. But we're capable of fixing them, you know, when they're that bad. That's just a pretty severe oil leak, a weld leak on a transformer, but we do a lot of weld leaks. And the benefits of online leak sealing for high voltage equipment is there's no need to drain the oil or the gas or depressurize. Many repairs can be done under pressure that are energized. It depends on where they're located, and the sealant's non-epoxy. It's flexible and easily removed. And we can consider it now, since we've been doing it since 2002, as a time-proven process. And you can see the numbers are well over 17,000 jobs, and they're broken out into flanges, packings, custom clamps and enclosures, drain plugs, cover plates, tab changer flanges. Miscellaneous covers a lot of the weld leaks. I need to update that a little bit, and then CT boxes and CTs, we fix them by a repair technique we'll get into in a little bit. And here's our success rate on them. Some of them, you know, if it's not under the 92%, we may have had to go back out and reshoot it, repump it. And here's your business case for leak sealing these oil leaks or SF6 gas. Is the outage time required. With us, there's minimal or no outage required. You typically got to drain the oil. There's no need to drain the oil with us. And you've got processing, rigging equipment, storage, and personnel involved. Not required on our end when we do it. Extensive manpower on your end, just one staff observer, one of your guys out with our technicians to keep an eye on them when they're working on these transformers is all we require. And then advanced planning on your end, we're pretty much a quick response compared to what you guys would normally have to do. And then the cost, there's a cost savings considerable to it. And this is some of the injection equipment that we use. The injection equipment, as far as the pressure gauge and the injection gun is involved, because that's a handgun, so we can control the injection process when we pump it, instead of doing a pneumatic and pumping it in there real quick, because it's more of an art pumping the sealant than it is a science. The material is a 2-part sealant. It's mixed with a catalyst, and down to the left you'll see where there's a nylon clamp and an injection valve. That's a 1/16 inch NPT on the nozzle end, if you want to call it that, going into the tubing. The other end's a 1/4 inch NPT. Those are what we inject through, but when we're done, we let the sealant cure, and then we pull these and plug them when we're done. And sealant's not a silicone, so silicones can foam the oil. So ours is, there's no silicone involved with our sealant. And this is really our bread and butter repair right here, where we can, let me see if I'm going to screw something up here. If I get rid of this, there. Okay. It's where we're doing a drill and tap technique into the flanges, the face of the flanges, where if it's a 4-bolt, we like to try to do it in 4 places. If it's a 100-bolt, we like to do it in 100 places, if it's like on a top cover plate or something like that. And the reason for that is you have to have those multiple injection ports so that when you pump our sealant, you can watch it move around that gasket and migrate around the gasket. And so you don't inject a lot of pressure at one location. It allows our sealant to flow because we're removing some of that gasket when we drill into it. So you can see where there's a groove on most of this equipment, and that's where we're drilling into that, and our sealant will channel that groove when we inject it. And then on the right side, you'll see down at the bottom here, the packing gland, where we can go in and drill and tap those. We loosen up the follower and pump them on that style. We can do some with O-rings too, where we just inject the O-ring. And here's a in progress repair. And this was, totally done while the leak's active. And if it's low, if it's on a corner, but if you're still far enough away from anything that's hot, we can do this energized. But you can see where we've installed our 16th-inch injection valves. We drill and tap the face of the flange. We go in with an 1/8-inch bit. We drill it so deep, then we come back out and drill it out with a 1/4-inch bit, tap the hole, and we hook the valves up and drill through into the packing or into the gasket area on something like that. A lot of times when you pump this, you'll start pumping here and you'll look at this other valve, you'll see oil come out and then our sealant. They're not all exactly like that, but a lot of them are, where you can tell that sealant's moving around there. This particular one, we could only do it in 3 places, but it'd be still a guaranteed job. Let's get to the next one. This is a packing, where we can come in here and do these packings, and we loosen up the follower over here on the left and drill and tap here. And then when we're done, we'll let it cure and we'll pull our injection valve out and put a pipe plug in, and the valve still remains operable. And again, if this is just an O-rings type where you can't adjust the follower, we can drill and tap and hit the O-ring. They're both a guaranteed repair. The guarantee is a 2-year guarantee on these repairs. But we've had repairs out there now over 15 years, and we haven't had any problems with them. But again, the guarantee is 2 years. But after the 2-year period, if we come out for new business, any old jobs, we'll reshoot them at no charge if it's within 70 miles of the old work, or the new work. We'll do old work too. So that's a pretty good, that's a strong warranty. And sealant, we've had our sealant checked by an independent lab for dissolved gas analysis and dielectric strength. And again, it's not a silicone. Silicones can foam the oil. And we've had it tested down to -40 F or C. And again, I'm talking about it's flexible material, has a memory, it'll expand and contract, and it's easily removed. Here's some of our sealant that we're pulling out of a clamp. It may not all come out exactly that easy, but the point is it's not an epoxy, and it's going to be a lot easier to remove since it's a pliable material. And here's a top bushing, bottom flange. We could probably do 2 of these if you had it grounded and de-energized in a probably 6 hours. We could get 2 of those done if there were 10 or 12 bolts. We're hitting a groove on them. That's just an in-progress repair. And pedestal flange or turret flanges we do. Typically, when we see flanges like this, we call them scallop, where at the bolt locations, it's open. So what we're saying is everything we've seen out there in the industry, if the flanges are metal to metal, the second flange under there's a smaller flange, but they're metal to metal and it has scallops to it, all of them had a groove inside that bolt circle. Typically, that groove is about a 1/2 inch behind the end of the bolt circle. And you can see over here on the right where that's where we plugged them with our pipe plugs when we were done. And this is done on a larger cover plate or tap changer where we can come in and drill and tap these. And then all these would be pulled and plugged. This is in progress when we do it. This was when we were using injectable bolts. We've gotten away with that pretty much now using an injection lug or an injection ring. I'll show you that in a second. But I said we don't, on the epoxies, we will use some in an instance like this because a lot of these flanges have a crush preventer bar in them that runs along here, so you can't overcrush your gasket, but there's spaces in them. So in those, that there's a space in there. So we want to make sure when we pump our sealant, it doesn't extrude out that space. So that's where we would use an epoxy to retain our sealant while we pump that groove on something like that. But you can chip that off of there later date too. It's not like you've injected the inside of that that groove with a straight epoxy. This is a cap nut where an injection lug where we can use these. You can't see it, but there's a machine groove in here where when you install this, it's capped off on the end, and then our sealant, when we pump it, will run down to the stud bore. And these are injection rings. Typically, you need longer bolts, but we put longer bolts in and put an injection ring in there. It'd be over here. These are probably long enough where we could use them on that. This here is epoxies. Sometimes customers use them and stuff, but they're about 50% effective, and I'll read this statement. Most epoxies set up rigid and do not take expansion and contraction as well as a pliable sealant. Additionally, sealant injected inside a clamp will have some compaction, to whereas applied epoxy will not. So the epoxy doesn't move as good as our pliable sealant does, and these are repairs that were made by the customer. This repair here is how we would do it. The threads are leaking over here on the left, as you can see, and we'll make a clamp. It closes on the hex, goes over the threaded connection, and closes on the OD of the pipe. Well, since we got unequal bores on the clamp, when you pump it, if you didn't have set screws, where I got an arrow pointing to a set screw in there, it'd want to push that down the smaller OD. So we have to be concerned about that. So we have to tie the clamp down. So once we install it, we go in here, we pull the, it's usually a 1/4 inch set screw, pull it out, run a drill down here, dimple the shoulder of the hex on 180 degrees away also on the other side, and then put the set screw back in so it holds it in place. This other one is where we would eject it, and then we pull and plug our valves when we're done. This one here was done recently on one where we removed the epoxy the customer put on, and over to the right, we're going to make a clamp that closes down. We've removed the epoxy that closes down on the hex. It's actually covering 3 leak areas here, 2 bushings, and then a bushing going into a nipple. That's really where the leak was, but this clamp covers all 3 areas when we put it on here. It's designed to close here and then up here, and it also has the set screws in it. This over here to the left is showing one of the set screws that would go in. The other pictures are just made it taken at angles where you can't see the set screw, but there would be some in the back. There'd be another one on the right and then 2 in the back also on this. Leak detection and repair program, LDAR. We do that. We've done it for a couple different customers. You'll see here in a second. Some of the questions you ask is, can you re-gasket or replace? How soon? Can we afford to wait? Severe leak, environmental concerns, compare costs of different solutions. This here is just one we did for United Illuminating, where we're doing a program for them. These are knock-on caps. I'll show you that in a second. What that is these knock-on caps have a Labra seal to them, like it's crunch teeth. I'll show you in a second, but they're designed to get to knock them on the half coupling right there, and then you put the set screws down on it to keep it from moving when you pump it. We know what the ODs on those half couplings are from 1/2 inch through 2 inch. And here's what it looks like. These are machined to a point. They come like a V. They're machined 5 to 10 thousandths undersized, so they knock on there, and you got an interference fit so it retains the sealant when you pump it. These are the set screws. Once you knock it on, you pull them out, you dimple the side of the half coupling, and you put them back in and pump them. If you ever got to go back in there, you can loosen them up and knock them off with a hammer. But that's what they look like when they're installed. They're on our trucks. We keep them on the trucks. This here in a tap changer packing repair. Obviously, nobody's going to move on an energized transformer a tap changer, and this one's locked in place, so you can't. But we've done these energized, and some of them we've done not energized, because sometimes they get it's pretty crazy the way they're designed. Sometimes you got to tear into them a little bit to get to where the gland is to pump them. But this particular one, we went and added a nipple and a coupling and drilled behind here. You can see the follower over here. We loosened it up, went back here and added a nipple and coupling, 16th inch NPT, and then pumped it and sealed it and then plugged it when we were done. On these motorized tap changers, we just got to make sure that the motor assembly is taken out of service while we get up in there so it doesn't move when we do it. But this is where we would drill and tap one like this right in here to seal it. And this is a clamp that we put on. This is a tongue clamp. This particular one, it had a gap over here on the left. That one we put the clamp on did too. This is a tongue. It's designed with those teeth. They'd be oversized about, again, 5 to 10 thousandths, and they wipe out as you in between the inside face of those flanges as you install it. It's just to retain our sealant when we pump it. But on this particular one, we had to move the tongue all the way to one side because of the wall of the transformer and install it. We had to offset the ears too to fit it in there. And then all this, these valves, and this will get cleaned up when we're done pumping it. This was done within 36 hours. Normally, we'll come out and measure something up that if it's going to require hardware, and we'll measure it up early in the morning and we'll have it the next day, unless it's something super big or whatever. I know this job was done within 36 hours. And here's what our techs typically do if we got to measure something up. They'll go up here, out there, and they'll take their measurements, get a sketch together, and they'll give it to engineering. And I'll tell you what, well over half don't even require engineering, but some do. If they do, if you guys do, we certainly can provide calcs and drawings. Sometimes assembly of views you guys will like because you can see what's going on better, but this is just showing an engineering drawing. And then the clamp, this top one here is actually a strong back because this is called a hub seal clamp. We'll get into that more and show you what that looks like in some pictures ahead of us here coming. And it's just to draw the clamp forward, but that was sealed on an SF6 gas leak. And then we provided the calcs with pressures, temperatures, and then some of the stresses involved making the clamp, welding specs, all the different materials that are involved in making the clamp. And then this particular one on the smaller transformers, I call it's leaking through that bushing where the porcelain, and I call it the terminal end, or the aluminum terminal end there comes through there, it's leaking. In fact, we got one in Kansas City I just quoted yesterday that we're probably going to end up doing, but it's leaking out of here. So we're going to make a clamp, a nylon clamp with fiberglass bolting that'll close on the OD of the porcelain. It'll come over and close on the OD of this terminal end right here. You can see like it's a gusset at 12 and 6 o'clock, a little space. Here's what the clamp looks like because it's going to close around that gusset. And here's where a groove is in these two places where we put a rubber seal in, fiberglass bolting and a nylon clamp. That's it installed and that's it being pumped. And naturally, you know, when we're done, we pull those metal valves and plug it with a plastic or nylon pipe plug when we're done with it and seal it. Certainly these are down and grounded when we're doing these. But you're looking at a 2-day deal. Come in the morning, measure it up, get the clamp the following morning and do the job. So this is on larger bushing on a generator step-up unit where we had to close on the aluminum part of this bushing and then go over the leak and onto the porcelain. And this is how we sealed it. And again, we'd pull these and plug them when we're done. I see where a couple of them have been done. This was one where we were okay with an aluminum clamp on the bottom, but then it started, the leak moved and it was leaking between the porcelain and aluminum. So we had to go with a nylon clamp and we figured out a way to attach it. So we went with a double clamp that way on this one. And on all our clamps, we make sure there's no sharp edges or corners. So we'll have them all ground where they have a curve to them or they're rounded. This one we couldn't get into drill and tap, so we went ahead and put a clamp on this one and sealed it off. These are dresser couplings. We get into a lot of these. They don't have a groove where you can drill and tap that flange, so we have to enclose them. It's just the nature of the beast, and then we fill them and seal them that way with an enclosure. This particular one's a weld leak. If you look close there, you can see that there's a plate that we had welded on there, just a 3x3 plate, and in between that and the clamp, we had we use it as a jack bolt between there. We got a 1/2-inch bolt with nuts on each end and opened it up so we could push that clamp forward to, you know, from right to left forward. And then underneath, you can see the strong backs pushing the clamp up, and then we injected it and sealed it. because we were able to do it and give you a guarantee by doing this, because we can pump our regular pliable sealant versus trying to peanut shut and using epoxy. And we do that occasionally, but that'd just be a best effort repair. It's better to get the guarantee. This particular one was leaking, and if you look over to the left, just as an illustration, it was a weld leak over here. The right one we fixed, but it was a weld leak that had a crack on it. So we dimpled the end of each weld in hopes to keep it from migrating, cracking. Then we took cracking any further. Then we took a piece of bar stock, square bar stock that's about 2 feet long, and we machined the one corner of it off and put a groove in there with a seal. And then we used these C-clamps to actually close onto the gusset over here to the right in both places, and a jack bolt that pushes the clamp in place, and we injected it and sealed it. And this was all done when the transformer was energized and run. And this was the only one we had a Learjet fly this in for on this particular job. And this one here was leaking. Now this is a crack penetration, a 6-inch crack on this weld, and they're concerned about it coming apart too. So this is a little more complicated, but what we did here on the left, you'll see where the arrow is. That's actually the clamp. It's a hub seal. If you look close, you'll see the packing. It's a, no, I think it's either fiberglass packing or, what am I thinking of? Teflon packing that's in there. But, and then this closes on the pipe. But this particular device here is called a friction strongback, where it doesn't close all the way on the line. You just tighten it up so you can jack bolt at 12 and 6 to clamp forward. But before you start jack bolting that clamp forward, because now you're trying to pull the line out of the transformer, so you don't want to start putting any force on that just yet. That's why if you look over to the right, we had to add a strong back tie down, line tie down, if you would. On the left side, you'll see a jack bolt that's coming through this heavy duty angle iron and over here. So we can tie this line down before we start jack bolting these down. This is what that looked like. We had the plant help us, and they fabricated this heavy duty angle iron, and that's how we put it on there before we started jack bolting at 12 and 6 on that strong back there. And that allowed us to be able to get a successful repair. This one here over to the right, they were concerned about the line separating on here. Now we're going to make a hub clamp on this, and the hub clamp pushes up against this bottom. It's really a header run. If you look over to the left, it's unifins is what it is, and it's the bottom header run on a unifin section, and it's leaking out of here. So we're going to make a hub clamp with a seal that pushes up against here and closes around the OD. And this is the clamp. If you look close, right here is the hub seal. Okay, we still have to add our seal in there, but that's the groove to put a seal in there. And then this part here closes on the OD. These are lugs. The bolts on the job you just looked at before this picture, one bolted, everything's tight, then you pull one bolt at a time. You put this lug in, and this jack bolt here goes through the threaded part. That's what that looks like right here, where you do one at a time. Now we can push the clamp forward, but before you start putting a bunch of pressure, jack bolting heavy on that, we got to make a tie down device. This was a little complicated to make sure everything was tied down. So we went above it and below it, so that because there was actually coming off of here, that was a unifin too, and it was a header run. There were heavy duty eye bolts that were on there that we run the angle iron across. And then on the bottom, we had these bars that we welded in place. It actually, you can't see it, but it had jack bolts that grabbed this flange on the bottom. That way it ties the line in before you go up and do heavy duty torquing on this and then pump it. This particular one was pretty unique. It was an emergency job where we went in here and we went ahead and it was leaking at 180 degrees from each other. And so they were concerned, 2 cracks, they were concerned about this leak. And so what they ended up doing is we put a ring down here that had fingers that would go between the bolts. You'll see that in a minute. And then the hub clamp, again here, it hubs up here, closes on here, but we got to tie everything down. I didn't want to show that to you right away because it's pretty busy looking. Here it is. This is what the strong back is with those fingers under there. And we tie the clamp down. We go over the top to tie everything down and seal the leak. That's actually the clamp. This one here was on a cable, a static old cable spreader, where we went in there and sealed it off on the cabinet. Where we did here is we went in and we put we give them an example on what that'll look like, just a little design. And then we ended up getting the job quite a couple years later, actually. But this was a design we made. That's a floating end plate. That's got a groove that'll have sealant put in it. And then it closes down around here. And that's, let me see here. Let me go back one here. Over here on the right, that's what the enclosure looked like when we were done. This particular one was an isolation repair. This is how they had it looking before we got there. And we saved them from going in and taking this transformer. It's going to be $1 million for them to come in there and take this transformer out of service. So what we went in and did is we did an isolation on here where we come in here. If you look behind these bolts, there was about a 1/4 inch groove all the way along that stretch. So we put a pin, a 1/2 inch square in here. We pounded it back, and one on this side of the bolt, pounded it back. Then we put plates over here and had them welded in. And then we used epoxy on the very ends to make up the difference to retain our sealant when we injected them. So this is what that looked like when we were done. And we pumped it here, here, and here on each one. And that isolated it here. We had to do that isolation here and at the very end one. And then we pumped between there and sealed it off. These are unifins where we go in and we can make a weir for, because we don't know which one of these leaks. After years of vibration, these they're flared up underneath there is how they're sealed on the inside of that header run. And we can make a weir on these. The only thing is you're going to lose some cooling. You'd be surprised. We've done this at a few nukes, and they seem to be more interested in either slowing this leak way down or sealing it, and not that concerned with losing the cooling. But you're never going to really get back into there once you pour urethane in there. But what we're doing on this is we're making a weir plate, and we use an epoxy at the seams so that when we pour urethane, it doesn't leak through there. And then this is the urethane in there. And that's just the back side of it. We do more of these weirs than the other one, actually. If you can imagine up here, in fact, the report that I did for you guys, that you'll see, the 3-page report, I get into more detail how we do these. But the theory behind these is pumping about 6 or 8 inches above where it's leaking. And then our material will cure. And if we ever got to come back in, we can drill and tap the weir and inject our sealant behind it. It's just that our regular sealant behind it. Now you got something to bridge against. CTs, we do them. This CT here, sometimes we got to fill them. Actually, more times than not we do. And you're not going to get to them. It's a lesser of two evils. This particular one, we got a cap where we can go in here and we can remove the one of the wires, take it off, put this back on the cap here, and it sticks through here, put the wire back on and inject it and just seal that area. These are with clamps, that type CT, but a lot of them, like I say, we fill, but it's just the nature of the beast. These are actually oil leaks down here on the bottom that we put clamps on. On the right, this is a bus system. Again, this is that friction stromback where it doesn't close all the way, because where this clamp, this is on an SF6 gas leak. They're unequal bores. And what we're doing is holding that clamp in place while we inject it. These are repairs we've done well over 200 for Con Ed up there, where we put different clamps on different valves. Some are aluminum on the smaller ones, but you can see some of these different clamps that we put on theirs because they had the LDAR program in place. This was for PSE&G, just showing a few different leaks. This is a top cover plate we did for Toronto Hydro, where we can do these two, the full face gaskets. We might have to drill more holes. You always got to drill the stud bores because that's where the leak's going to go. Sometimes on a full face gasket, though, we find ourselves chasing the leak a little because it's not like a groove that'll channel the sealant. And we might have to drill between these stud bores to get the seal. This was on a SF6 gas bus system where we went in and we enclosed this. They didn't want, enclosed the flange. They didn't want to seal here or here. They didn't want it to touch. So this particular one here, it's just their drawing. This, the tech drew it up here. This is showing a drawing that we had sent them. We're going to use a nylon insert, give them the calcs, a nylon insert here with a groove. We'll put a seal in there. That way you can see it keeps it back from the pipe from touching. And then this here, we pour our material, finish injecting it. And that's what it looked. We replaced this. I guess it's a grounding strap. This valve will get pulled and plugged when we're done. And they went in and they bagged it after we were done. These are other SF6 gas leaks on clamps that we installed and sealed. This was on a clamp, again, the strong back deal, closing on the over the weld and sealing that off. This was actually casting where it was leaking through. We made a clamp, a strap clamp. We'd put a seal around here, and that'll go over the leak, and then we wrap the straps around the pipe and seal it that way. This was done at a, actually we did 2 of these repairs for Farley Nuke within the last couple of years. It's a leak on a motor lower bearing reservoir, and they were having to put a gallon in every day, and they didn't want to do it anymore. So this is what that looked like when it was apart, but they didn't want anything drilled and tapped into these O-rings. So you can see it was spinning. We did this while it was actually spinning. And this is where the leak is. If you look close, you see where it's leaking. We're going to make a clamp that has a hub seal that pushes up against here, covers everything, pushes up here. We'll change these bolts out one at a time, put a longer stud in with a nut, and then that stud will stick through our clamp after we get a bolt pattern. They just didn't want us, but we have to install a guard before we start doing that, because they don't want any nuts or whatever dropping down into this spinning shaft. That was a big concern. So over to the right here, you'll see where we had a fabricated additional guard put on, and then there was a clamp. We got the bolt patterns and installed it and sealed it, and that's what it looks like installed and sealed. I know that's kind of quick, but you guys can always come back to me. This stuff will be put up on the forums website, and you can get a hold of me anytime on any of this stuff. We can talk about it longer if you want. But this particular leak, we used a nylon clamp for. We're going to close here. We're going to go up over this area and close here. It actually will cover 2 leaking areas. This is just illustrates where the leak was. Over to the left, that's showing how much room I got to actually adjust it to be able to get our hardware in there. You'll see here in a minute. That's where the leak is on the left. Over to the right is the base plate. Now we're going to put a clamp. This clamp on the right will actually seal right in here. We got to give it a little room, so we'll show you what that looks like at the end. But that's the clamp. The interference fit on the right side, that's just a nylon clamp. It will be just no more than electrician's tape. We'll wrap around there but this side we put a groove on because we got the room, so we're covering 2 spots. Here's where the clamp goes. Right in here, we want to keep it at least 3/16 away from this edge so that we get sealant penetration in between the edge of the clamp and the leak. When we pump it, and over here to the left, we're covering this cap when we close here. And that's what the clamp looks like. Add some sealant extruding there. We were able to adjust this, put it on, and then pump it with our sealant and plug it up to seal. This particular one here was done with it was offset a little bit to the right. So what we ended up doing here, because we got to close here and then up here, we were going to make a floating end plate on this so that when we do this job, we can we can align it. See, these were drilled and tapped in the field so that this goes on first, it closes on the bottom, then we put this on, then we mark the holes, then we drill and tap it. So if there's an offset now, we won't be tweaking on that porcelain. It's real important that when we close it, because the packing seal will go in here too. And that looks like, you know, that's filling it up. This is a gasket we put in there when we were done, you know, during the process to get our sealant to retain in there when we injected it. And then just to make sure we weren't going to touch that top skirt when we pumped it. And that's a completed job on the left. And that's me thanking all of you for attending the presentation. I know it was kind of quick, but you know, if you want to, you can take a screenshot of this. You can get a hold of me anytime. And I've got a lot of before and after pictures. And if anybody's got any questions, I guess we got a couple minutes.
We have a question from someone asking, how do you find out if Sf6 is leaking? Is there a monitor?
Typically, the customer's already found that for us because the only thing we can use is Snoop. So it has to be fairly substantial to pick it up with Snoop. And that's typically the customer's got to tell us where it's at. And usually laser imaging is the best way to do it. We don't actually locate the leak. We have the customer tell us where it's leaking, usually at the end of a bushing or the top of a bushing, and then we make the repair. But if we can't check it with Snoop, it's got to be done by an outside contractor, or normally the utility has laser imaging where they check it.
I have another question. How quickly can you perform custom fabrication if it is required for a project?
Usually within 24 to 36 hours. It depends on how big the clamp is. But I got one now that we're going to measure in the morning and have it installed the next day. It depends on, but usually within 36 hours, but a lot of times customers send me pictures, and I should have mentioned that. If you send me pictures, I can certainly quote and give you an idea of how long by just looking at a picture.